Welcome to Calc Chat 6. Today we're going to learn about what the integral is and how to find the area under a curve. So far we've discovered that the derivative is the slope of a tangent line. So given any point along our curve, we are able to find the slope of the tangent line to that curve. That's been the basis of our derivative. We've been focused more on the top part of our curve by using the derivative to find the slope, but now we're going to focus on the area under the curve, which is called the definite integral. So to find the area under these curves, we need to use what's called the definite integral. And it is basically our way to find the area under our curve. It does have a special notation for this. So this little squiggle line, that's our integral. So what this is saying is it's saying the integral of f of x from a to b. Also, we can think of it as the area of the curve, under the curve, f of x, on the interval a, b. So the one confusing thing you might be saying to yourself right now is, what does that dx mean? So this dx basically just means with respect to x. So we're not finding any y values here. We're really focused on x values. And so a and b are always going to be x values. And so that just means what we're finding the area under the curve with respect to. So given this example, y equals 9 minus x squared, we're asked to find the integral from -3 to 3 of the function square root of 9 minus x squared. And first thing we get to notice about this curve is that it's a semicircle. So we don't really have any tricks for definite integrals yet, but what we're going to talk about is how we can use our geometric prior knowledge to look at integrals. So if I notice, this is all above the x-axis. And so my integral is all going to be positive. So if I remember, the area of a circle is pi r squared. In this case, we're looking at a semicircle, so we're just going to take 1/2 pi r squared. If we go from the center out, we can find that our radius is 3, and I can check it all 3 ways, and it should be 3 all 3 ways. So when we write this, we write the integral from -3 to 3 of 9, the square root of 9 minus x squared dx. We can write that it's equal to 1/2 times pi times r squared. And so we get 1/2 times pi times 9, and I'm just going to leave it in terms of pi, 9/2 times pi. So that is our integral, or that is our area under the curve from -3 to 3 of the square root of 9 minus x squared. Here we're given the function y equals x, and we're asked to find the area under the curve from -3 to 6 of x with respect to x. So when I'm looking at this, I notice that I kind of have 2 triangles. So I have this first red triangle, and then I have this second green triangle. So I'm only given that it's from -3 to 6. So I know that this side of my triangle is 3, and this side of my triangle is 6. But what I need to know in order to find the area of a triangle is the height, because if we remember, area equals 1/2 base times height. So how can I find the area of the height for these triangles? Well, I can simply plug in my x values in for my y values. So when I plug in, or my x values into my function, y equals x. So I'm given -3, so when I plug in, if I make a t-chart real quick, when I plug in -3 for x, I get out 3 for y. So this side I get 3, and if I plug in 6 for x, I get out 6 for y as well. So my height down here is -3, my base is 3, and then over on my second triangle, my base is 6, and my height is 6. So whenever we have a curve that goes under the x-axis, the area we're going to be dealing with, we say, is negative. So this area, since it's under the x-axis, is a negative area. This area in the green above the x-axis, we're going to say, is a positive area. So when I'm finding the area of the negative part, I'm going to take just take 1/2 base times height. So I'm going to take 1/2 3 times -3, and I get -9/2. When I find the area of the second green triangle, 1/2 6 times 6 is 1/2 times 36, which is just 18. So when I do this integral, so when I'm finding the integral from -3 to 6 of, we know our function x dx, we have to split it up into the positive and the negative part. So I'm just going to take -9/2 plus 18. So if I can change this, -9/2 plus 36 over 2, I'm going to get 27 over 2. So this is my total area, or my total integral for from -3 to 6 of x. So here we're given a piecewise function. So we're trying to solve for 2 integrals at once, because if I notice, my circle is under the curve, or under my x-axis, and so it's going to be a negative area. My triangle above the x-axis is going to have a positive area. So I need to split, again, this whole integral up into 2 sections. So just taking my circle's area, I notice, again, it's a semicircle, and this one has a radius of 2. So I'm going to just take 1/2 pi times 2 squared. And again, this is going to be negative, so I'm going to add a negative sign. So here I get -1/2 pi times 4, so I just get -2 pi. So that's my area of my semicircle. Now looking at the area of my triangle, I see that my base from 2 to 5 has a length of 3. And in order to figure out my height, I'm going to have to plug in my x value into my function y equals x minus 2. So when I plug in 5, I get 5 minus 2, I get 3. So this height is going to be 3. So now when I take this area, I'm going to use my triangle area, 1/2 base times height, 1/2 3 times 3, and I'm just going to leave this as 9/2. So when I'm taking my total integral, when I'm taking my total area under the curve, again, I'm going to have to split this up. So I'll say this is equal to -2 pi plus 9/2. And since I have something in terms of pi and something that's not in terms of pi, I'm just going to leave it as is. So if this is you right now, please write down any questions that you may have and come to class letting me know what we need to work on. Please like and subscribe. Make me the top YouTuber on this YouTube. Thanks for watching.